I see a green light in the middle. There we are. Okay. All right, everybody. We're just a tiny bit late. So, first of all, I want to personally thank all of you for coming tonight. Are there any people who are here tonight for the first time? Just a little show of hands. A few people here. Okay, great. Well, word keeps getting out, and we'll do, hopefully we'll see more and more. All right, so let me introduce to you Guy Forsythe. He is I guess we'd say retired instructor, educator, kind of like myself. And he is the founder and chief executive officer and head dishwasher for Crying Rocks Ministry, singular, and based out of Sedona. And aside from the book table, he has one of the trapezoid tables has several of his newsletters, full color. And if I remember correctly from previous meetings, take as many as you think you need that you can distribute, because we want to get information out to other people. So that being said, if there's any other credentials you want to list, Guy, then you're free to do that. So go ahead. Please welcome Guy Forsythe.
Okay, let's try from here. Crying Rocks Ministry is a ministry in Sedona, Arizona. We moved there in 2003, and in 2004 we started the ministry. Oh, that's dead. Okay, and it's my wife and myself, and that's it. And I shanghaied an attorney to be a third board member, so if I ever get sued, I can hopefully get that taken care of. We have a website that you can go to and see all of our old newsletters if you want to. The newsletter that we put out looks like this. It's got up-to-date stuff on what's new. This one is out there, and it's got information on the carbon fold in Carbon Canyon at the Grand Canyon. It's also going to be in the presentation tonight. It's one of the three evidences of the Noah's flood at the Grand Canyon. And this is mailed out to, we're up to about 11,100 houses and businesses in Sedona. We mail it every 3 months, so this is issue number 80. And 81 just went to the printer at the end of last week. So we keep putting things out for the public. Again, you can see any of them on the website that's cryingrocks.org. So the scripture I like to use as the heart is Proverbs 26, 4 and 5. Do not answer a fool according to his folly, or you will also be like him. Answer a fool as his folly deserves, that he not be wise in his own eyes. And we know that all of the naturalists, the evolutionists, are fools because they are atheists, or the vast majority are. And Psalms tells us that the fool says in his heart there is no God. And so we want to take what they have produced in the way of evidence and show them from their own evidence that their conclusions are simply inaccurate. It just doesn't work. So defining a couple of terms, creationists and naturalists. A naturalist is somebody who is a materialist and an atheist and does science. Now, one time a naturalist was just somebody that liked to go out into nature and explore or whatever, but it's now, I use the term at least, as someone who is a materialist, which means they don't believe there's anything except matter, energy, and the laws of physics, and you can explain everything with those three things. And they are atheists, materialists, and then naturalists. And of course, creationists believe in an intelligent design creation. The main difference between the two, creationists believe that the earth is about 6,000 years old. In fact, the entire universe is about 6,000 years old. And it's been about 4,200 since Noah's flood. So Noah's flood would have been about 1,800 years after creation. Naturalists believe that the sun was, and actually Earth, very shortly after, came into existence about 4.6 billion years ago. And what's really important is the last 560 million years, because if you look at all of the rock strata that's out there, they'll tell you that the oldest strata, with a few exceptions in the Grand Canyon and other places, the oldest strata out there is about 560 million years old. And that's when life suddenly shows up in the strata. That's when the strata shows up on top of the bedrock. The real action is in the last 560 million years. We're going to look at something that significant that happened, and that's the carving of the Grand Canyon, actually the deposition and carving of the Grand Canyon. And we're going to look at 3 lines of evidence of Noah's flood that we can find at the Grand Canyon. And these are in the order that I find them exciting, I guess is the best way to put it. Injectites, they're kind of exciting, but they're very limited in their scope. So we'll say it's one of the weaker arguments. Because remember, all arguments are weak or strong, but you give them all, including the weak ones, because the weak work with the strong and build up a foundation of lots of arguments. And by argument, I mean a line of evidence. Folds is number 2, and as I said on the newsletter, we have the Carbon Fold and Carbon Canyon, and I'm going to be talking about that fold as well as others in the Grand Canyon. And then the one that really excites me is groundwater sapping. And you won't find creationists talking about this, and I don't know why, because it is just a fabulous, fabulous evidence for the carving of the Grand Canyon rapidly, very quickly after being deposited. And it's not just a little localized area, it's along the entire Colorado River all the way up to Colorado, including the entire Grand Canyon. Every square mile of the Grand Canyon has this evidence of sapping. So let's start with injectites. Here's an injectite. It's sticking up out of the ground, so you can think of it as ejecting or injecting out. It's actually injecting because it was actually created underneath and forced up. This one right here is about 150 feet tall and 50 feet in diameter. It can be found at Kodachrome Basin State Park, just south of Tropic, Utah. And geologists come from around the world to study this injectite because in the North Sea, wherever they find an injectite, they find oil. So they're very excited about injectites and they want to learn as much as they can about them. There's a paper out there by Ariel Roth called Clastic Pipes and Dikes in Kodachrome Basin. It's open access. You can Google that and pull up the entire paper. And this is a chart from the paper. And what they're showing is what's inside the earth. So like this is an injectite that starts down here, and then this part is showing now. Here it is coming up, and this part is showing. Now that's called a pipe, or the injectite is also called a pipe, which is derived from water pipe. An amazing thing happens, and I found about 10 water pipes in Sedona, of all places. And a water pipe is where, I'll be showing you, when you look down on the top of it, you can see that it's come from somewhere else. And I'll explain exactly what that somewhere else is. And we can start with right here, because look at these injectites. They start down here and go up. And what happened was an earthquake occurred while all of these sediments were wet. And we're looking at 1,000 feet here. All of this sediment was wet. An earthquake occurred, and many secular scientists, naturalists, believe that earthquake occurred in New Mexico, of all places. And that shock wave comes out, and earthquakes are crazy things because they have points of resonance. So you might not be anywhere near the earthquake. Well, you see it happen all the time. The earthquake that collapsed everything in San Francisco back in, 78 or somewhere around there? 89. That earthquake occurred a couple hundred miles south of San Francisco. But the shock wave it hits points where it kind of resonates, and that's where it does the damage. And there's a place in Sedona where we have an area of resonance with an earthquake that's about a half a kilometer square. And these happen. So this resonated here, and when it did, you had all this energy coming, and somehow it punched up material from down here and punched it up through all these layers. So it was sticking in the layers, and then these eroded, and now we have these pipes sticking up. Now it's called an injectite because the material that it's coming out of is different material from where it started. This is a different layer of sandstone than this layer right here. Okay? So if we look at this a little closer, I wanted to show this because it's interesting in that the material that's shot up there, most of it is what geologists call massive, which does not mean large in any way, shape, or form. It just means there's no lines of strata. So you look at it and it's just a plain surface. You don't see those strata lines in it. That's a massive surface to a geologist. But in this, which is mostly massive, are some areas of a little bit of strata. Just kind of chunks of strata, blocks of strata. Rather small compared to the overall thing in terms of diameter and that sort of thing. And John Whitmore and Ray Strom did a paper published in Sedimentary Geology, and this is the premier geological journal for sediment geology, sedimentary geology. Everybody gets published once. He published this, it was accepted, it passed peer review, it got published in Sedimentary Geology, and then everybody goes, hey, wait a minute, he's a creationist. So when John and I did a paper on the Coconino, we sent it to Sedimentary Geology, and we were rejected immediately. Because every creationist gets one paper in a secular journal, and then it's gone. So John investigated sand injectites at the base of the Coconino Sandstone at the Grand Canyon in Arizona. So here is a contact between the Hermit and the Coconino. This arrow is pointing to the contact and the top of an injectite, and that injectite comes right down here, so this arrow is also pointing at the injectite. This injectite, instead of coming from material down below and punching up, is coming from material above and going down. Okay? Kind of different. And he found quite a few injectites. Here's 3 of them. That's a really cool one right there. And you'll see it's not round because it's actually cracks in the Hermit, and the Coconino fills these cracks. So these cracks may not be real wide, but they may go 50 or 100 feet or 200 feet back into the side of the hill. We don't know how far because all we can see is where it's exposed. This is a rose diagram. It's not a Venn diagram. If you're into Venn diagrams like Kamalia, sorry, we're going to have to transition to rose diagrams. This diagram it shows each individual injectite. Down here it shows where they're located, and it shows how big it is. So the size of this tells you how big it is. Where it is shows you the location. And I've drawn the Bright Angel Fault in orange here, so you can see where that is. And you'll notice that these are kind of concentrated around the Bright Angel Fault. And what's interesting, remember, these are kind of a slot. They're in a crack, they're not round, and so you can get an orientation for it. And the orientation averages out to be perpendicular to the Bright Angel Fault. The fact that they are perpendicular to the Bright Angel Fault and biggest at the Bright Angel Fault is an indication that there is a direct relationship between the Bright Angel Fault and these injectites. Okay, because that's just the way geology works. Now, the Coconino was supposedly, when I give anything more than 6,000 years, I'm giving you what the naturalist says. Okay, I don't believe it for a second, but this is what the naturalist says. Coconino deposited 270 to 265 million years ago. The Hermit deposited 285 to 275, so you've got at least 5 million years between deposits. When you go to Sedona and you see that vertical red rock, about 800 feet tall, it is between the Hermit and the Coconino. Okay, but it doesn't make it all the way to the Grand Canyon. So at the Grand Canyon, these two are right together. And this, see how flat that is? That is tabletop flat. And it is everywhere it is seen in the Grand Canyon. So you're going up the two sides, back and forth into valleys and that sort of thing. Probably 1,000 linear miles of this contact, and it's perfectly flat everywhere, which means there was no erosion between when this was deposited and this was deposited. 5 million years, and apparently it never rained. Conclusions that John came up with, John and Ray: evidence at the Hermit-Coconino contact suggests the sand-filled cracks formed before the Hermit and Coconino were fully lithified. Lithified means hardened. So somehow all this happened after they were deposited, but before they were hardened. Well, how's the Hermit going to sit there for 5 million years and not start to harden? Okay? The lode cast-like features associated with the sand-filled cracks along the Hance Trail also suggest the Hermit was somewhat unlithified during crack filling. And the reason I wanted to show you that one area of that one at Kodachrome was to show you there are chunks in there of what appears to be stratified rock, but yet it's just small little chunks. So as the injectite is occurring, it is breaking off little pieces that end up having that strata in it like that. Small bits of Hermit within the sand-filled crack show that the Hermit may have been at least partially lithified. So these rocks were not completely hard yet. And in fact, the Coconino appears to have been deposited in water in these cracks. Because if the crack was there and the sand just poured in as sand dunes were moving across the top of the Hermit and the sand just poured in, number one, you would not get chunks of strata. Something had to bang into that to knock off the chunks of strata. And it just doesn't look the same. When it's deposited by water, it looks very different from when it's deposited dry. So here's our chart again showing this. This kind of shows some of the overlay of the rock that is there and what's going on. You got 10 million years to the top of the Kaibab, and there was at one time another mile of strata on top of the Kaibab. Believe it or not, actually a mile of, I should say, sediment, because it was all washed away at the end of Noah's flood as it drained off. Naturalists and creationists agree with that, because when you go north into Utah, you find the layers, and if you go to Mount Humphreys in Flagstaff, you find remnants of those layers in various places on the side of Mount Humphreys. So we know that those layers went clear across a mile thick at one point, across the top of the Grand Canyon, across the entire area down to Flagstaff, and who knows how much further south. Very well could have been over Sedona also. The significance of this: these are not shrinkage cracks. The naturalists say, well, what happened was the Hermit was there, it dried out, and as it dried out, it cracked. The Hermit is a mudstone, and you've seen mud that settles after a rain and it dries out and it cracks open. But it only does that if it has lots of clay in it. Clay is a size of particle and then also can be different materials. But you have to have a lot of clay for cracks to occur. The Hermit has almost no clay, so it's not cracks. It's not shrinkage cracks from drying. The cracks are not like known shrinking cracks in their structure or appearance, in addition to there not being enough clay. The Coconino looks like it flowed in water, and this is all in this paper. Small blocks of Hermit and Coconino in the cracks means that they'd both started hardening, but were not completely hard yet. They were still mostly wet sediment. The big thing is the timing. Anybody know when the Bright Angel Fault supposedly occurred? About 50 million years ago. But this contact is over 200 million years before that. So if the Bright Angel earthquake or fault generated the cracks in the Hermit, the coconino would have been in place, hardened across, and there would be no coconino down in those cracks, no matter how they formed, because it would all be hardened by the time that the fault occurred, 200 million years later. So this is evidence that this material was deposited, was still wet when the Bright Angel Fault occurred, which means there was also another up to a mile above what's available at the Grand Canyon now. And all of that happened very, very quickly between deposition, the cracking, and the filling of the crack. So what happened was those cracks opened up because of the earthquake before the coconino was deposited, and then the coconino washed across and covered it over. Now keep in mind, the creationist scenario of the flood has all of the strata deposited by day 150 of the flood. The top right here, I believe, was done by the 40th day. So we have real fast time here. The 40th day to get this deposited, the crack occurring, the coconino to flow down in it, and then just another 100 days before we're done depositing, and then washing away with the draining of the flood. So the Hermit and Coconino should have been solid rock for over 200 million years before the Bright Angel earthquake, but they weren't. The naturalist scenario just doesn't cover it. Now, again, these just cover a small area, so let's go to something that takes a little more area, and that would be folds. We're going to look at one fold in particular, and that's the Carbon Fold. Here we have the Colorado River coming down through here. The little Colorado River comes right in here, and if you've ever been to the Desert View overlook, you can see where the little Colorado comes in. And then Carbon Canyon is just a little ways down. At Carbon Canyon, you can follow the canyon up, and right here is where the folds are, right at the edge. And there was a fault there. There's a big fault, and it'll be obvious to you when we zoom in a little closer. And when I did my raft trip, we hiked up here, and then we hiked another 2 miles down here, and the rafts came down and picked us up down here. So it was a nice hike back in there too. Okay, this is looking down from Google Earth. Notice the strata here is going vertical. The strata here, we're looking at the top and we're seeing strata lines like this. This strata has been scooped up. Here's pictures of it. Right there's the what's called the hinge of the fold. Okay, so think of it as a hinge when you fold. That's where it's tightest. There's a person. There's the top. And you see back here, this is looking away from the river. So it's actually flatter back here and lower back here. You gotta have a ridge from the river back in about a mile, and then it's down low again and actually slopes very gently from there. You can actually hike a trail down to this point if you're crazy, but you can do it. It's a long trail. But notice how this rock is sticking up, and we don't know how high it was sticking up when it first occurred because it's eroded on top. The material's gone. It could have gone up another 100 feet, and it's probably already a couple hundred feet tall right there. Okay, so there's the Tapete Sandstone. This fold we're going to look at is in the Tapete Sandstone. This is what it looks like from the South Village. And the reason that we want to investigate the carbon fold is for decades, the naturalists have said the carbon fold is the result of slow and gradual processes of pressure and heat over many, many millions of years, and that can bend the rock without cracking it. That's called ductile deformation, also known as metamorphic rock, okay? Because it's been exposed to heat and pressure over time. Creationists have said, no, it's soft sediment deformation. In other words, it was deposited, and immediately after it was deposited and hadn't hardened yet, but started to lithify, started to get those strata lines in it, then it was folded. And you can fold over rock. It happens today sometimes after floods where rock kind of get convoluted as it flows down a hill after the sediment's been deposited. So here's why it's a big fight. If it's ductile deformation, then we're going to see changes in the crystalline structure. Because when you look at it, a geologist looks at it and says, oh, that's sedimentary rock. The naturalist says, no, it's ductile deformation. Because the naturalist thinks that this was formed by a fault that occurred 50 million years ago, at the same time as the Bright Angel Fault. Only this one's to the east end of the canyon. So they think it happened 50 million years ago. Well, of course, all of that rock would be hard if it was deposited. That's in the Tapete sandstone, which was deposited over 500 million years ago. It isn't going to sit there and stay liquid or unhardened for 500 million years. It just isn't going to do it. So they have to say it's ductile deformation. We believe that at the end of the flood, we started having all of these earthquakes and rock moving up and down and faults and all of that. The sediment was still soft and it pulled it up. The one side came along, lifted up, and as it lifted up, I can't curl my hand. It lifted up, it curled it back. Okay? Now, this is such an important thing. In 2013, I was asked to help Canyon Ministries get started on the rim tours. And for 5 years, I drove up from Sedona and gave 8-hour geological tours of the South Rim. And I'm sorry, any of you have that happen? A lot of you kind of have the same coloration I do, and I'll assume you understand. So on this, as part of that, they wanted me to take a raft trip because that was their big bread and butter up until then. And so I went on a raft trip with Andrew Snelling. And on that raft trip, Andrew Snelling was supposed to take samples of the carbon fold, rock samples. And since I had done research on the Coconino with John Whitmore and we'd done rock samples, I was supposed to help Andrew take these rock samples. But he did not get his permit in time. They kept delaying and telling him, no, you have to do this now, and you have to do that now, and you have to do this other thing before you can get a permit. And every time he'd do something, they just kept adding to it. It got to the point where they were asking for things that simply can't be done. So around 2018, Andrew applied for a Freedom of Information Act. He wanted all the documentation regarding his request for a permit to take samples. So the Park Service had to produce it. And in it, it was blatantly obvious from their communications with other geologists who absolutely hate creationists. One of them lives about 8 miles from me, 4 miles as the crow flies. They didn't want this done. The naturalists did not want this done because we were going to take samples and take a look at them and see, oh, do we have that crystalline structure change that you're talking about? They didn't want it done. But when a court case was filed, Andrew sued them, And within a few weeks, they capitulated. And they not only gave him a permit to get as many samples as he wanted to get, they even gave him a permit to take 2 rafts on its own journey just to do the sample collection that they were going to do. And that is a good thing, because if Andrew and I had to collect those samples, we're on a trip with people that, geology's cool, that's why I'm at the Grand Canyon, but let's move it on. Okay, a typical tourist. And that's okay. But to collect those samples, it probably would have taken Andrew and me, 5 hours, maybe 6. That's one of the reasons I don't hike with people in Sedona. I go by myself, because if I find something cool geological I've never seen before, I may be there 3 hours. Because it takes that long just to start getting a feel for what's going on, because you got to figure out the context. It's kind of like studying your Bible. Yeah, there's a verse, but what's around it? You got to study all of that. So they got to go take their samples. Since they had 2 rafts that they could take, they took along a film crew from Answers in Genesis. John Whitmore went with Andrew to do the sampling. They had a few other people along to do commentary and stuff. And someday I think we're going to see a cool video come out about it. So one of the arguments that, and I point this out because these things aren't cut and dried. One of the arguments the naturalists used to say that it was slow and steady over time from heat and pressure is these gaps. There's a gap here, there's gaps here, there's gaps here. If it was soft sediment deformation, they say, as it bent, it should have all filled in. Okay? And that's a legitimate statement. That seems logical. But if the material had begun to lithify and it got folded and these gaps occurred, it would possibly have enough structure to it to not just fall apart. And when you see the sapping that we're going to look at later, you'll see that very well happens. That strata, even though it's still wet, hasn't lithified, but it starts to be able to hold itself together. And that's because as sand compresses, the grains start interlocking with each other, and that forms an interlocking system that holds it together. Geology is so cool. On the other hand, if this was done slowly over time and this was hard rock, any place there's a gap, that rock should have shattered and fill it with debris, because there's nothing supporting it. You got this open place, you got this thousands of tons of pressure on the side of it. It should simply explode that rock into that space, but it didn't happen. So Andrew sent his samples up to our favorite thin section guy up in Calgary, Canada, which is Ray Strom, who did the paper with John Whitmore and also did thin sections for our study on the Coconino in Sedona. And these are what are called thin sections. The blue is epoxy. It's colored blue so it really stands out when you do it. So what they do is they take a sample that's not very big, inch and a half on a side. They put it in a pressure chamber and they inject it with epoxy. So the epoxy penetrates all the way through this thing. Then they take it out of there and they cut it into slivers 30 millionths of an inch or 60 millionths of an inch thick. And then they polish it so that it is 30 millionths of an inch thick and very flat and smooth. And then you put it in a microscope and shine a light through it. The rock is so thin you can shine a light through it at that point. So what you're seeing is a cross-section of the rocks. Now, if this was brittle deformation, like the naturalist says, we should see microscopic cracks in here, particularly along the places where their adhesive is holding them together. We should see them crack and joint. And even individual crystals should have some cracks in them occasionally. Nothing. They pulled 60 samples from the carbon fold and then also from the Tapete sandstone, several miles from the carbon fold. And then there are another 2 or 3 folds along the Tepete sandstone where they took samples, as well as a mile or 2 away from it, so they could compare in the fold and every place else. And all of them look the same. There's no difference in the samples between in the fold and outside the fold, which tells us it's soft sediment deformation. And that is disastrous for the naturalist. How can you explain that being done? And Andrew went crazy. He did luminescence. I don't even understand luminescence or polarized light. That's luminescence, that's polarized. I have no idea what they mean. These are so exotic. I have no idea. But it should help show up those defects. And they aren't there. He also did microscopic, electron microscope views at it, so you can see what these look like, and you can see each one's a little higher resolution, and you can actually see the grains there, blown up very, very large. And again, you don't see fractures and cracks like you would expect if the naturalist was right. So all the data points to soft sediment deformation. That means the sediment had to be deposited at the very start of the flood, because it's the Tepete sandstones, the bottom layer in the Grand Canyon, and vent near the end of the flood when all the faulting was occurring. So 6 months later, that's when it's folding. And Andrew's just gotten started. He's published several papers on this now. He's going to be publishing more related to this. He still has to publish on the other folds at this point. Any questions? Okay. The final thing is groundwater sapping, and this is so cool. This is along the Colorado River in Canyonlands National Park. See these divots on the side? There's a Jeep road. But you got these canyons, and they're steep all the way back into the very back. They're very steep. Look at that beautiful semicircle. Those are called amphitheaters. And they're all along the Colorado in Canyonlands, all along it. And my wife and I went there about a year ago, and there's a placard there at one place that says, "The rock cracked and water got down in the cracks and expanded, and that broke the rock, and eventually it created these side canyons." Well, if you know anything about how rock cracks, it doesn't happen in the middle of a flat surface. It happens at the edges of a flat surface. So if the river's coming down here, and originally this plateau was just a nice line that came through here, the cracking is not going to occur going deep into these canyons like this. Also, when you get normal erosion, you don't have a level bottom all the way to the back. This erodes first, and then it slopes and slopes more. And at the back of this should be sloping. These sides should be sloping down. They do a little bit, but not much. It doesn't look like normal erosion. Now, what's funny is you go there and you see this placard that says this ice did it and everything, and then you go look at papers. And I got really fascinated by this about 5 years ago and started digging up all the papers I could find that you could get to. And of course, most of them, there's a paywall. Oh, that'll cost you $35. Well, I don't have that. But usually abstracts tell you everything you need to know, and you get to see the abstract. But with all of this, the Park Service saying, here's what happened. Here's what's in a paper from the Geological Society of America about the sapping processes and the development of theater-headed valley networks on the Colorado Plateau. Theater-headed valleys in the Glen Canyon region of the Colorado Plateau indicates that groundwater sapping is the predominant mechanism of growth. These canyons occur in the Navajo sandstone. That's not what the scientists, they aren't saying it's ice that's chipping it away. They're saying it's groundwater sapping. Groundwater sapping. This is so cool. I don't know why creationists don't just jump all over this, because it is so cool. This is an experiment that was done. This is sand. This is a screen that sand cannot go through, but water can. This is the water line, and this is a drain. So imagine this as the Colorado River carving down, and here you've got this sandstone and other stone to the side that has lots of water in it. What happens? Well, here's the device where they experimented, and here's what happened. Here you have the plateau, here you have the river, the drain, and here you have groundwater sapping. Look at those cool amphitheaters, the straight vertical walls, rounded at the end, very little debris at the bottom. That was caused because the sediment there, and this is the Navajo sandstone, at least out in the real world, not in this experiment, was deposited during the flood and should have gotten hard. The water should be gone after 50 million years. You know, they're talking about the Colorado River cutting down over millions and millions of years, starting just 50 million years ago. Well, all that rock would have been hard, fully hardened. But yet, this can only be done in water that is saturated. And when I say that, I'm not going to get into the process of evulsion real deep, but basically when sediment is deposited, there is water between the grains of sediment. And then over time, because of the weight up here, the sediment's pushed together, the water is squeezed out. You ever watch a wave come in? The color of the sand changes, the wave goes back out, the sand is usually darker, and then you can just watch it follow the wave out as the sand comes the same color as what the water didn't go on. That's evulsion. The water coming in saturated the sand, lifted it a little bit so water got between the granules, and then as soon as the water left, because you're only talking about almost a microscopic layer, it's very thin, maybe a 1/16 of an inch, the sand immediately compresses again and drives out the water. That's evulsion. All of this should drive out the water. All of that weight, just like at the Grand Canyon, there was at least another, well, from this layer at Canyonlands, there would have been another half mile of sediment when you look at the mountains around it, and then another mile on top of that for millions of years. This rock would be hard. Here's what's really cool. You want to read a paper about Mars? Thickest paper I found. It was 58 or 60 pages. And it was all about groundwater sapping on Mars. You know, you can have a flood on Mars that covers the whole planet and makes canyons and does sapping and everything, but you can't have it on Earth. Go to Mars and show me the water on Mars, and I'll show you some water on Earth. Okay? Now, I've got videos, and this one I think actually the video is embedded, so it should work. And then we'll see how the YouTube, how we are connected to the internet, how well that works out here. So here is groundwater sapping. The groundwater is coming out from the left, going to the right. You can see it sloped slightly downward. But notice there is not a deep drain like you would have at the Grand Canyon with the Colorado River charging through there. So you're not getting, like in the experiment that I showed you before where you had those nice round amphitheaters, you're not getting that so much here because it's such a gentle slope. But notice at the head end of every one of these, it's semi-rounded. And naturalists and creationists both need to go back, and wherever they found a canyon that goes back, they need to reevaluate how that canyon formed looking at the head wall of it. Was it caused by sapping? If you've got a real vertical wall there and no splash pool where water came over and dug out, you've probably got groundwater sapping going. Well, you can see you've got these nice rounded canyons this time. You've got a nice rounded one over there. And notice there's almost no debris along the bottom. The naturals say, well, if the Grand Canyon was carved quickly, When the sediments were still wet, there should be lots of debris on the side. If the debris that comes down on the side gets washed away by the water that's sapping out, what's left behind, and sometimes there is some slope because it wasn't as well compacted yet, especially if it's in mudstone, which is very poorly cemented compared to sandstone or to limestone. Now, let's take a look in the Grand Canyon. Look at that amphitheater. And it flows down. It goes through the Muav limestone. This is the Redwall limestone. Look how vertical that is. And look how thin it is. It's not like water came through here and went around here and did all that. This is sapped out. Now we go down to the Bright Angel Shale, which is mudstone. Mud is not as well cemented, so it slopes instead of a vertical surface. And then when we get down to the Tapete sandstone, we get more vertical again. What's wild is that the Grand Canyon, you look anywhere you want, anywhere. And in the Redwall limestone, you will find amphitheaters. This is my favorite. It's visible from the Grandview overlook, but it's out there a ways. You got to kind of look for it. But look at it. It's a triangle. The water sapped out. There was so much water in this that it was able to sap out in 3 directions and still leave this beautiful flat-topped cliff in the middle. And in the background, you can see where there are canyons that go back in that are also, once again, very steep-sided. This is not an isolated part of the Grand Canyon. This can be found in every square mile of the Grand Canyon in the Redwall limestone. The Redwall limestone is nothing except sapping. Nothing else. So the Colorado River comes carving down. You've deposited all of this stuff over 500 million years. The Colorado River carves down along the side, and you get sapping 500 million years after it was deposited. When it's solid rock, it can't have. I think this is the greatest testimony to Noah's flood that there is, and the rapidness of it. It's just incredible. And it's not just in the Redwall limestone. Let's see. Oh, this is in the Redwall limestone. This is going back Bright Angel Creek. That was a drainage area that came down and caused amphitheaters on the side. And here it is here. It's everywhere. It's absolutely everywhere. And it's also in the Tapete sandstones. There are some areas in the Tapete sandstone where you get a little bit. It's not a real pronounced like this one, but you actually get an amphitheater in that. So we've looked at injectites, folds, and groundwater sapping. Does anybody have any questions? Yes, sir.
The injectites, you mentioned at the beginning about the possible earthquake associated with them. Is that like when you heard a barrel fluid? You know what that is? There, you see photos of they use sound with oil and things, and it creates peaks and spikes because of the harmonics within the fluid. If there was an earthquake, you're saying on a massive scale, and a harmonic could drive up those types from the vibration.
All geologists believe that's the case, yes. Okay. And if you look at the injectites, you look down on a flat surface and all you see is flatness because the strata's on the side. But you look at the injectite and you can actually see strata lines, and they're concentric circles. Okay? And that's in a water pipe. We have 2 injectites in Sedona that I've found. They are actually the same material, but we know it's from a different layer because in it's about this big around, and there's a white ring and another white ring. And if you go off to the side and you look, you see down about 30 feet, there's a white layer, and then down another 10 feet, another white layer. So it came up through there and grabbed it. And if you ever go to Sedona and you read a book on why the rocks are red, they will tell you because groundwater either came in and eroded away the red coating that's on the sandstones, the sand grains, or the water came through that was saturated with the iron and deposited it after the rock was hard. Those injectites on Coxcomb prove that it was deposited that color. It was not groundwater that happened later.
Here we go. I have two questions. My other question is, okay, you showed us Canyonlands in the Grand Canyon. Would Canyon de Chelly also have been probably caused by that too? Because when you get back to the very end, there's no evidence of a paleo river coming into it to carve it out. So.
I don't know what's on the outlet of Canyon de Chelly that would haul the sapped material away, but most likely, I mean, at the end of the flood, there was drainages all over the place. So yeah, as I think about Canyon de Chelly and the vertical walls and all of that, and that's Navajo sandstone, just like Canyonlands.
Okay.
So yeah, that probably is sapping.
I was just saying, it's another area of research, and yeah, the sapping component. I mean, when you go to the South Rim, like you say, no matter where you look, you see these beautiful things. You say, how would the little Colorado over here have scooped all that out?
Yeah, it can't.
Doesn't fit. Other questions, please?
That question is kind of unrelated to tonight's topic, but it's geology in a sense. I'm from California originally, and we escaped there to come here. And I've noticed in the last 2 years a lake formed close to where we live in a lower area, and the soil in there after 2 years is still suspended in the water. I mean, it looks like a mud puddle, you know, and it's got to be at least 6-7 feet deep, but it never seems to settle. And I'm wondering what's so different about the soil here that it would remain, you know, suspended in the water.
It may be less dense than water, in which case it's going to try to float, so to speak. I'm kind of baffled by that kind of thing too. I see it, but I'm kind of baffled by it. But if you go on Google Earth and look at where like the Mississippi goes into the Gulf of Mexico, the Mississippi's brown, it hits the Gulf of Mexico, and then it's clear. So and that's going in all the time, but it's clearing itself. So something weird goes on in these small puddles that I don't know.
Quarter mile size.
Yeah, I don't know.
This is a rock work assignment for you.
Uh-huh.
You're going back to Sedona. Are you going to be going through Payson?
No.
Oh.
I go up to the freeway bay. You're talking about a few miles north where the Tapete sandstone
Mile marker 270 where there's
is
a shaft.
exposed.
Yeah.
I actually got 3 samples. As Andrew was doing his work, he emailed me and said, get me 3 samples from that area. And to give you an idea, to get 3 samples there, I was there 5 hours. The first thing I did was explore in every direction, so I could find places where I could find a place where it looked like, okay, if I take a sample here, here, and here, I'm going to get a nice average.
That's a tough cut.
Yeah, but if you kind of go off to the right, you can get up on it, and then it's pretty easy to climb. And then, you know, that's. So I got him 3 samples. And did you ever see his Genesis history? Okay. The guy that directed that, Tom Palfrey, he wanted a chunk of Tapete sandstone about this wide, this tall, and this long. He wanted to put it between 2 supports and then break it and see how strong it was. So I also got one of those while I was there. I did not chisel that one out of the ground. I took a piece that was floated off to the side on its own. John Whitmore happened to be going from California back to Ohio and spent the night with us in Sedona and picked up the samples to take to Andrew. Any questions not related to what I covered tonight?
All right, another one here.
Any comments about the, I don't know how to pronounce, the Paleo dig site near Payson?
Okay, he's talking about the paleo site that's on 260 as you're heading from Payson out to come up to Heber. So the place, it's called Paleo Site, and they found there's artifacts and stuff there.
I'm not familiar with it.
Okay. It's so picked over by now that I don't know that there's a whole lot there. But just the other day, my wife and I and some friends visiting us We were just barely west of where the Highway 260 comes out from Christopher Creek, and like where the lane is to merge onto the highway, heading westbound. There's a bunch of layers in there, and if you go up and walk up to it and you kind of look around, there's one layer that's very loosely lithified, and there are closed clamshell fossils in there, and you can pick them out with your finger. And some of them, after each summer snow and stuff, they will fall out and be on the ground. And so closed clamshells mean that they had to be buried quickly because they didn't have time for them to die and the shells to pop open. And they're just laying out there. And we heard about it from a friend who heard about it from a realtor. All right. Oh, you know where Christopher Creek is? Okay, you come down off the rim, you go a few miles, and then the old highway went into Christopher Creek and then comes back out and merges onto 260. It's where that westbound merge starts to come back in. And then on the side of the road. And then it's the same thing on the other side of the highway, but again, there's no really good place to park over there. But it's the same layers. And most of them are about the size of a filbert. I mean, as a hazelnut, okay? But some of them are about as big as a walnut. And they're beautiful. They're gray. They're not colorful or anything like that. But they're obviously clamshells. You can see the little ridge lines in them and things. And so free for anybody who wants to take the time to dig them out. So